Hey everyone, hope you guys are doing well. So in this video we're going to be implementing a 3-tier architecture of a video streaming platform. This was basically a project which we did for one of our client, and we thought that there is so much you guys can learn from this video. So I thought let's implement a minified version of this project and discuss these things with you guys. So this was a project which I've done for my client, but again, when you implement any production grade application, there are so many things which goes into it, and not everything can be demonstrated in a YouTube video. So I have removed few things from the actual implementation, but still this particular implementation is good enough and worth implementing and worth watching. So like I mentioned, this was an edtech platform, a video streaming platform. So for any video streaming platform or for any platform that stores data, it must have a storage service. Okay, so for this particular project, the storage service that we used was S3. We used S3 to store videos, and then to serve those videos we made use of CloudFront, and we created a CloudFront distribution and give access to this S3 bucket using an IAM role. We created an IAM role and assigned that to this CloudFront distribution and said this CloudFront distribution can access this S3 bucket and can read content or can read the files in this S3 bucket. So this was for the storage of videos or objects and how we serve them. Then comes the actual meat of this project. So let's jump right into this and let's start discussing things from the VPC level. So we created a VPC. In that VPC we implemented everything, and we implemented things in multiple availability zones, so that even if something goes wrong in one availability zone, we still have another availability zone serving our application. So since this was a production grade application, so we have to follow the best practices, and for best practices for networking is that segregate your application layers in network segments. So we created a private subnet for database in both availability zone. This particular subnet for database in AZ1 and subnet for database in AZ2. And we created the database using RDS, and the engine that we used was Postgres. So when you create a database using Postgres, and more specifically RDS, what AWS does is it spins up the primary in one availability zone and then created a standby in another availability zone in this one. Okay, so this is what we have done, and we store the database credential in a secret. And why we stored this in secret, I'll explain this in just a moment. Then we created another layer of subnets so that we could host our backend application in this layer. So this particular subnet is for hosting our actual application. So in this subnet we spin up an EC2 instance, and in that EC2 instance we deploy our application. And to make things faster and to make our application fast, we made use of elastic caches so that we don't have to go to the database every time to fetch things, and so that we could cache the data. Okay, so we made use of this elastic cache. So to connect this EC2 instance with this database, we have to have the database credentials, right? Those database credentials were stored in this S3 secret manager, and we created an IAM role and assigned that IAM role to this EC2 instance and gave the permission to this IAM role to read the secrets from the secret manager. So this was for the backend subnet. Then we also created another EC2, another IAM role, and assigned that IAM role to this EC2 instance. This time the role was to allow our EC2 instance to perform action in this S3 bucket, to store data in this S3 bucket, to read, write, and perform updates in this S3 bucket, because all the write operations in our S3 bucket will go through this application which is hosted in this EC2 instance. Then to expose our application to external world, what we have done is we have created a load balancer, and this load balancer resides in the public subnet. Since this is in public subnet, so we can access this load balancer from outside world, and this will then forward the traffic to our EC2 instances that are running our application. And we created a bastion host in this private public subnet, so that we could access these these EC2 instances in this private subnet for deploying our application. And then comes the security part, which is also something really important for any production grade application. Our database subnet is only accessible from this security group, meaning only our private backend applications can access this database. Our database is not accessible from externally outside the VPC, and not only from outside the VPC but also from any other subnets other than these two subnets. And our backend application, which is in these two subnets, is only accessible from this security group, meaning only our load balancer can access our backend application, or only our bastion host can access these EC2 instances. So this is how we implemented a really robust, strong, secure architecture. And let's jump right into the code. There I'll explain the Terraform code through which we achieved this architecture, and then once we are done with the Terraform code, we will then demonstrate the backend code, and then we will show you the application, and then we will perform the demo. Alright, so we implemented this architecture using Terraform. So let me explain the Terraform code. So this is the folder in which I have written all the Terraform code, and here are all the resources which we have created using this Terraform. So first thing first, we spin up the VPC. This was the slider of our VPC, and then we created public subnet 1, public subnet 2, backend private subnet 1, backend private subnet 2, and then DB private subnet 1, and then DB private subnet 2. So basically we created 6 subnets, just as we have demonstrated here. So this was for the networking part, and then let's go to the S3 one. This file we created an S3 bucket, and then we created a CloudFront distribution, which is basically these two things, the S3 bucket and then the CloudFront distribution. So this is the code for the CloudFront CDN distribution. And then here we created the IAM policy so that the CloudFront distribution could access the S3 bucket. Let me show you. This is what we have. This thing we have implemented, this policy. Then comes the EC2 instance. We created a bastion host, and this particular bastion host goes into public subnet 1, as you can see. And then we created 2 backend EC2 instances, and they go into backend private subnet 1 and backend private subnet 2. And then the security group, if I show you here, the backend application exposes port 500, but they are only accessible from the public subnet 1 and public subnet 2. And they also allow traffic on port 22, but these port 22 are only available for accessible from public subnet 1 and public subnet 2. This is meaning that only our bastion host can access these EC2 instances in the backend EC2 instances. Then the bastion host also allow traffic on port 22, but it accepts traffic from all silo range. Because we need this bastion host to deploy our application, and we are using GitHub Actions to deploy our code to these EC2 instances, and we don't know the IP address of the runner that GitHub Action use. That is why we have kept this like this. Otherwise, if we directly deploy the application from our local host, then what we could have done is we could have added our IP here that and restrict the access to the bastion host to only from our IP address. But in this case, like I mentioned, we are using GitHub Action to deploy the code using the bastion host. So we don't know like what IP the GitHub Action runner has. So that is why this is this. Okay. So this is how we are deploying the EC2 instances. Then comes the RDS. We are deploying RDS instance, and the engine is Postgres, and then the secret, which I mentioned here, this one. In this section, we are creating the database secrets and storing it in the secret manager. Then comes the IAM role for the EC2 instances. We created this IAM policy, and what this does is it basically allows our EC2 instances to access the S3 bucket, and like it allows put operations, get operation, delete operation, and list operation on S3 buckets, and it also allows the EC2 instances to access secret manager, because our EC2 instance need access to the S3 bucket as well as the secret manager. So that is why we have this IAM policy, and we are attaching this IAM policy to the instance profile. Then comes the Elastic Cache. We are creating AWS Elastic Cache cluster, and the engine we are using is Redis, and this basically goes into the backend private subnet 1 and backend private subnet 2. Then the load balancer, we're creating an application load balancer, and it allows traffic on port 80. Let me show you. It allows traffic on port 80, and then it forward to port 500, and this port is basically what our backend application uses. So this is how we have implemented this Terraform code, and these are the variables: the project name, the environment variable, the environment that which is dev, the Amazon machine AMIs for EC2 instances, then the bucket name, DB name, DB username, password, and then the secret. And in the outputs, we are getting the bastion host public IP, EC2 backend private IPs, and then S3 bucket name, CloudFront distribution CDN domain name, and then the database secret ARN, and then the Redis host endpoint and application load balancer DNS name. So these are the outputs that we get when we apply this Terraform code. So what I'm going to do is I'm going to apply this Terraform code by using Terraform apply -auto approve -var file Terraform. Okay, let me actually go into the Terraform folder, cd Terraform, and then Terraform apply dash dash auto approve and dash dash var file is Terraform. I think it's not Terraform. Var file is terraform.org. So I'm going to apply this. This will take some time, and in the output it will produce the outputs that we have mentioned in this output.tf file, and then we are going to make use of those to deploy our application. So let me apply this code, and in the meanwhile it will take some time. I'm going to close this and let it run in the background, and what I'm going to do is I'm going to take it to the backend code and show you what we have in the backend. So what it does is it spins up the Node.js application on port 500, which is what we have specified, and then it creates a model in the database, media model. So if I show you the model, this is the model. It has the ID, it has the title, it has the description, URL, and type. So this is what the database model has. And in the routes, basically it has a slash media route, and whenever we send a request to this route, it sends the traffic to these endpoints. Here we have an upload endpoint, get all media endpoint, get media by ID endpoint, and then update media endpoint, and then delete media endpoint. And if I show you these endpoints in the controller, again, this is not for you guys if you are not, if you're just a developer or just a DevOps engineer. You don't need to worry about these code, especially the Node.js code or the application code. I'm just showing you for you guys. Otherwise, if you're unable to understand these code, then it's fine. No need to worry about it. So what it does is create media endpoint. What it does is it uploads the file in the S3 bucket using this upload file. You can see that I have a service, and if I go to this, this is the service which it is using, and it uploads the file to the S3 bucket and returns the what it does is it returns the CloudFront URL, and the URL that we can use to access that file through the CloudFront. Okay, and then what it does is it stores that URL in the database. So what it's actually doing is it's not storing the S3 bucket URL. It is storing the URL that is used to access the file or the media content from the or using the CloudFront distribution. So this is what it is doing, and rest is I think this is going to be a little bit difficult for you guys, so I'm not going to go in too much detail. Just to show you that we are using Redis here for caching, and I'm going to show you basically here where is actually Redis coming into picture. So in the GET request, let's suppose that we are doing a get media, right? Get media by ID. Here what it does is it tries to look for this media in the Redis client or Redis cache, and if it finds in this cache, it will directly return that. Here you can see, and if it is not present in the cache, it will then try to look for this in the database, and then from the database it will grab that media or the video and then send the video to the client. So this is how we're using Redis. Okay, and if I show you the front-end code which I'm using, in the front end, basically what we are doing is let me show you here. What we are doing is we are where is it? Okay, load media. So what we're doing is we're fetching the media, and in the response we get the list of the videos, right? And each video has the URL, and we are directly making use of the built-in video tag, and we are giving that URL as a source to this video. The reason why you're seeing this image is because this particular application was for both images and for videos, so that is why we have these images as well. But don't need to worry about this. This was you guys can remove this, but this is not your headache, because generally this whole application level logic and everything is handled by the developers. You guys being DevOps engineer, not need to worry about that. Okay, so this particular URL is basically I'm gonna show you this one. Here it uploads the video, and then that particular URL is saved in the database. And this URL is actually, if I show you this one, this is in the service.s3 service.js. So where is it? Service and s3 service.js, and this URL is basically the CloudFront URL. Okay, CloudFront, the URL that we can use to fetch that video using CloudFront. So our client application or our front-end application can directly access those videos using the CloudFront URL. So this is how we have implemented this whole application. And then let me show you the GitHub code, GitHub CI code. What we have done is, basically you guys can go through this. I'm not going to explain this because it will be the video will be too long if I go into every single line of code. So what it does is, just a minute. So what this code does is, it logs into, or it SSH into the SSH into this bastion host, and then from this bastion host is SSH into these EC2 instances. And in these EC2 instances, what it does is it take the clone of our backend code, which is this repository. It takes the clone of this whole repository, and then it goes into the CD into the backend directory, which is this backend folder here. CD is into this folder, and then what it does is it creates those environment variables which this application needs. These are actually the environment variables which this application needs: the database secret name, the AWS region, S3 bucket name, CloudFront URL name, Redis host, Redis port, and the application port on which the application runs. Okay, and it fetches all these informations from the secret. We're going to store all this information in the on GitHub's secret. We're going to get these details once we apply this Terraform code, and from there we will then store these details on GitHub secret, and from the GitHub secret, this deploy.yml code will then pull, and then it will then create the .env file, and then it just do the npm install here, npm install, and then npm start. So this is how it deploys our application in those EC2 instances. So let's check the terminal, and I hope that we did the Terraform apply at the start of the video, and this is now done with the execution of the Terraform code. And in the output, it has produced the load balancer DNS name, the CloudFront domain name, the DB secret ARN, and then the IP address of the two backend private hosts, and then the public IP address of the bastion host, and then the Redis host endpoint, and S3 bucket name. And also it has also created a SSH key. This SSH key will be used by the GitHub action code, so that it could log into the bastion host, and from there it then jumps into the backend host or where we deploy the actual application. So as I mentioned, because our GitHub action code needs these variables, basically these variables are required for our application to run properly. So this is our backend application. It has these environment variables, and these environment variables are provided by the GitHub action code. So we have to store these variables: the DB secret name, AWS region, S3 bucket name, CloudFront URL, Redis host, Redis port, and the application port in the GitHub secret. So it is reading from the GitHub secret, as you can see. So what I'll do is I'm going to copy each of them one by one. And so this is our GitHub repository, and in the settings tab right here we have secrets and variable, and on the actions tab we create these secrets. I've created all these secrets. What I'm going to do is I'll have to update these variables because I created these variables a few days ago just to test the working of the pipeline. So let me update. I think I have a little bit of a slow internet these days, so it's taking some time. I think AWS region is, we don't need to change it. It's, I think the region is US East 1 already. Bastion host IP, that is something which we need to change. It's taking eternity. So you guys can actually create these. So yeah, let's start to change. So the Bastion host public IP, I'm gonna grab it from here. Save. Update the secret. Okay, it's asking me to verify. So let me enter the verification code it has sent on my email. I don't know why it's asking for verification, but nonetheless we'll do the verification. So 8728 verify. So it's updating the Bastion host IP. So similarly we have to update all the other variables as well. So I'm gonna copy these two as well. And then update the, let's actually do one by one. So Bastion SSH key, that is actually here. I have to copy the content of this SSH key.pem. Oh, not like this. Control C, and then paste it here. Save. Then the CloudFront URL, let's grab it from here. Then the DB secret name, so that is this one, the secret ARN, or the name. We can use any one of the two, either the secret name or the ARN. It will work the same. So I'm going to copy the ARN and paste it here. then the port is for 500. All I have already set, so no need to change. This port is the application port, the Node.js application, which runs in port 500. I think I've already edited the port 500 last time when I tried this, so I'm not going to change this, but its value is 500. So the IP address of the private EC2 instances, I'll have to grab this from here, copy the two, paste them here, and they should be separated by commas. That is how I have written the code, and there should be no quotation. These double quotes should be removed. The two IP addresses of the two private hosts. And then what else is remaining? I think there is, yeah, this one actually. Let's check. So the Redis host is, I think we have to change the Redis host as well. So Redis host endpoint, Control C, Control V, and then the S3 bucket name, that should also be updated. So I'm going to copy the S3 bucket name from here and paste it here. And Redis port is running on the default port, which I've already set. So the port was, Redis port was 6379. So with this, our pipeline is ready. So what we can do is now go to actions, and let's try to trigger this. So this one, and actually what I can do is either I can push a change from here. That will also let me push this code. When I push this code, it will actually run the pipeline automatically. So what I'll do is git add git commit -m edit changes git push. So it's taking some time because like I mentioned, I have a little bit of a sluggish internet. So we're done with this push. So let's check and let's refresh. So as you can see that it has triggered this pipeline, and now that if we open this, alright, so as you can see that now the application is deployed, the pipeline was successful. So it's time to check the application. So let me show you the diagram once again. This was the diagram, the architectural diagram. Here we have deployed the backend application, and now to access the backend application we need to make use of this, the load balancer DNS, right? And any client application can talk to this application using the load balancer DNS. So what we need to do is, we have a front-end application already in this folder. So I'm gonna run this application in the browser. So I have installed this extension called Go Live. So with this extension, what you can do is you can directly run any HTML code in the browser. So this is the HTML code which is acting as a front end for this application. So I'm gonna hit this one, go live. As you can see that this is now our front end. So last thing we need to do here is we need to grab the URL of the application DNS, application load balancer DNS name. Just copy this and paste it here, because this is the load balancer URL which our application should use, right? So let's go to the front end. Let's refresh this just to make sure that it has now the it starts talking to the proper backend. So let me upload any file. At the moment this application supports both images and videos, but right now as you've already noticed that I have a slow internet, so uploading any video is not in wise decision here, because it will take eternity. So I'm going to upload an image from my smaller one, which is, I believe, a small image which we could upload a little bit faster. Is there anyone? Yes, I've got a small image here. I'm going to upload this one, and let's add some title here. Test image 1. This is a test image. Okay, so let's hit the upload button. It will take some time, and hopefully it will go through. I have a slow internet, that could be the bottleneck, but other than that this application is working seamlessly. So you can see that the upload was successful. So the upload was successful, as you can see. So let's click the OK button. I've tried to upload. I clicked the upload button multiple times because I was not sure whether the upload is working properly or not. That is why we're seeing multiple images. But I have a slow internet connection. That is why I had to do this. So otherwise this upload feature is working properly. So just to show you once again, all the read operation will go through this CDN, and rest of the operation, the write operations, any upload, any update, any delete operation or anything, all will go through this load balancer. Okay, so this is how we have implemented this this 3-tier architecture, and this is a production grade implementation. You guys can make this better. Obviously there is always room for improvement, but this is good enough to put on your resume if you are someone who is trying to learn DevOps, who is trying to learn AWS and its different services. But I feel this is already good enough.